Okay, we're continuing with sequences, learning the different skills we need to learn about how to work with sequences. Okay, in this video, we're going to be given a sequence, not the formula for a sequence, just we're going to be given the sequence itself, and then asked to determine the formula for the sequence. So here are all the problems that we're going to work in this video. Let's get started. Okay, so 2, 4, 8, 16. All right, the most common types of sequences, I haven't posted videos on these yet, but the most common types of sequences are arithmetic and geometric sequences. This looks to be a geometric sequence because each time we're multiplying by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so again, how you write a formula for a geometric sequence, I'm going to go through that in detail in another video, and I'll post that video probably before this in this playlist. But for a geometric sequence, like we're multiplying by 2 each time here, right? So our common factor, r, is 2. So first put your common factor, all right? Now raise it to the n minus 1, okay? Because well, I forgot to mention that we're going to assume that all of these sequences start when n is equal to 1. As I mentioned, I think 2 videos ago, that's not always the case, and that doesn't have to be the case. That's not a requirement for sequences that they start at 1. Okay, but that's a common convention. A lot of the sequences you'll see start at 1, or it's assumed they start at 1. For each problem in this video, that's what we're assuming. So okay, so n is equal to 1. When n is equal to 1, you get 2 to the 0 is 1, and then you just put your starting term. We're starting at 2. But this is a little different because, well, we could have just put 2 to the n, right? Because if you simplify this, you get 2 to the n minus 1 is 2 to the n times 2 to the minus 1, and then we got times 2 to the 1. Well, 2 to the minus 1 times 2 to the 1, just this goes away. This becomes 2 to the 0. Right? So our a sub n, we could just put is 2 to the n. Okay, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, etc. All right, so whenever you have fractions in these types of problems, what you do is so you say I've got a sub n, and then you just put your fraction symbol, and then you're pretty much doing you're determining 2 separate sequence formulas, one for the numerator and one for the denominator. Okay, but here though, each term has a minus out front, so let's put a minus out front here. All right, now just evaluate this a sub n. Just imagine we don't have the minus signs. Okay, so the numerator 2, 3, 4, 5, that is an arithmetic sequence because we're adding 1 each time, right? We're adding the same number each time. And again, I haven't posted the video on arithmetic sequences, how to evaluate the a sub n for arithmetic sequence. When I do, it'll be just before this video. But what you do is for arithmetic sequences, you start with, so you're adding 1 each time. So put whatever like 1 times n. 1 times n. If you're adding 2 each time, you put 2 times n, and that accounts for that you're adding each time. Okay, plus, and then just put whatever you need to put here to get the first term. So we're starting at n is equal to 1, okay, and we need to get 2 to start. So just put 1. Okay, so when n is equal to 2, you get 2 plus 1 is 3. When n is equal to 3, you get 3 plus 1 is 4. All right, now the denominator, 3, 6, 9, 12. Again, you're adding, this is another arithmetic sequence. You're adding 3 each time. Okay, so 3 times n. All right, now just put whatever you need to put to get that first term. Well, just don't add anything. 3 times 1 is 3, 3 times 2 is 6, okay? So what we have is, now just write this in the cleanest form possible. So n plus 1 over 3n with a minus sign up front. All right, minus 1, 4, minus 9, 16. Okay, so we're alternating signs here. This is called an alternating sequence. And the way you account for the alternating sequence is you just start off by saying, okay, put minus 1 and then put whatever power you need to make the alternating sequence. So we're starting with a negative. So we can just put to the n, because we're starting at n is equal to 1. Minus 1 to the 1 is minus 1. Minus 1 to the 2 is positive 1. Minus 1 to the 3 is minus 1. If we were starting with a positive number here and then alternating, you'd put to the n minus 1 power or n plus 1 power. Whatever, either one, n minus 1 or n plus 1, same thing. Okay, so now we've got our alternating sequence accounted for. So now just look at the absolute values of these numbers and determine the sequence, right? Because you can ignore the alternating sequence now because this takes care of it. So what do we have? 1, 4, 9, 16. Okay, well, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, and then 1 squared is 1. So we can say that if we start at n is equal to 1, so that's where we want to start anyway. So just put n squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So now just put this in the cleanest form. And then n squared, all right? Okay, so we've got a fraction. So let's determine the sequence of the numerator and the denominator separately. So the numerator, 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4. So that's just a factorial. You're getting a bigger and bigger factorial. That's pretty easy. So, right, this is 5 factorial, this is 4 factorial, this is 3 factorial, this is 2 factorial. So we're starting at 2 factorial. So we start n is equal to 1. Okay, n plus 1 factorial. So that's the numerator, the denominator, 2, 4, 6, 8. So 2 times 2 is 4. 4 times, well, no, you're adding 2 each time. So this looks to be like an arithmetic sequence. All right, so arithmetic sequence, we put 2 in, where we're adding each time, plus, and then just put whatever you need to do to get the first term. This is just add nothing, right? 2 times 1 is 2 plus 0. So a sub n is equal to okay. All right, so we got another fraction, but the numerator is just 1. Okay, so the denominator, 2, 4, 6, 8. So again, you're adding 2 each time, another arithmetic sequence, just like what we had before. Same thing as we had before. Just put 2 in, right? It's the exact same thing as we had in the previous problem. 2n plus 0. You're adding, it's an arithmetic sequence, you're adding 2 each time, so 2n plus whatever you need to put to get the first term. We start at n is equal to 1, so 2 times 1 is 2 plus what? 0. Okay, so the first thing I noticed is this is an alternating sequence, so you can just start by putting down what you know. Okay, so it's the alternating sequence, so we're going to have minus 1 out front to what power? To just the n power, because we start with a negative. Okay, so we've got that done. Now we can just look at the absolute values of these terms, because if we find the sequence formula for the absolute value of these terms, then this minus 1 to the n power will just turn it into the alternating sequence that we want. Okay, so for when you're trying to find the formula for any sequence, you can start with the most basic ones, see if it's arithmetic or geometric. So it's definitely not arithmetic, but is it geometric? So some of these have fractions, some don't. That makes it a little confusing, but okay, so 3, 9, 27. 3 times 3 is 9, 9 times 3 is 27, so maybe something with a 3. Something divided by 3. 4, 8, 16. 4 times 2 is 8. 8 times 2 is 16. So 2/3. maybe the r is equal to 2/3, the common factor. So 3 times 2/3 is 2, okay? 2 times 2/3 is 4/3. So yes, this is a geometric series where so let's write the formula for the geometric series. So to do that, put your r to the n minus 1 power, or just make this start to where this is r to the 0 to get 1. 1 times your starting factor. You see? Because you get 2/3 to the 0 gives you 1 times 3. We start at 3. Then each time you just want to multiply times 2/3. So 2/3 to the 2 minus 1, 2/3 to the 1 times 3. 2/3 to the 3 to the 1 to the 3 minus 1 power, so 2/3 squared, right? 2/3, so 3 times 2/3 times 2/3. But this is an alternating sequence, so we've got this out front to make it the alternating sequence that we want. Okay, now just write this in the cleanest form that you can write it in. So let's say 3 minus 1 to the n there you go. Okay, 5, 8, 11, 14. All right, so is this an arithmetic sequence? Let's check the basic sequences first. So 5 plus 3 is 8, then 8 plus 3 is 11, so it looks like we're just adding 3 each time. So this is an arithmetic sequence. So we put 3, whatever we're adding times n, okay, plus whatever we need to make the first term, to give us the first term. So when the first term is n is equal to 1, so 3 plus what gives us 5? 2. And that's it. N is equal to 1, 3 plus 2 is 5, n is equal to 2, 6 plus 2 is 8, n is equal to 3, 9 plus 2 is 11, etc. Okay, so we've got a fraction. Well, and this is also an alternating sequence, so let's take care of the alternating sequence portion first. Minus 1 to what? Well, we start with a positive number, so we're going to do to the n minus 1, or you could do plus 1, saying it would give you the same result. Because whenever n is equal to 1, you get minus 1 to the 0 is 1, positive 1. N is equal to 2, you get minus 1 to the 1 power. That's a negative, minus 1. And so that alternates. So now just look at these without a minus sign, and you find the a sub n. Okay? So we've got fractions, so let's start with the numerator. All right, 1, 4, 9, 16, 25. That looks like you keep squaring, right? 2 squared is 4, 3 squared is 9, 4 squared is 16. Yeah, so in our first term is n is equal to 1, and so just n squared. N is equal to 1, 1 squared is equal to 2, 2 squared is equal to 3, 3 squared, etc. All right, the denominator, 2, 3, 4, 5, 6. You're adding 1 each time. Arithmetic sequence. So 1 times n, and then just put whatever you need to put to get the first term. And that's your answer. So now just write it in the cleanest form you can. Okay, so this one I couldn't figure this out when I first saw this one. When I looked at the answer, I was kicking myself. What do you know that alternates? How can you create this? What can you use to create this? Again, you're alternating between 1, 0, minus 1, 0, 1. Think about that. You keep alternating from 1 to 0 to -1 to 0 to 1. What does that? What function does that in all of math? There's a function that does that. Sinusoids, the sine function or the cosine function. Okay, so we're going to use the cosine function here because we're starting at 1. So cosine of 0 is 1. So since n starts at 1, we could say maybe cosine of n minus 1. When n is equal to 1, you get cosine of 0 is 1. Okay. When n is equal to 2, you get cosine of 2 minus 1, cosine of 1. That's not 0. Okay, so maybe we do this. Maybe we say pi. We add in, it's n minus 1 times pi, right? Because now we're going to be more in that domain of the cosine function. Okay, so n is equal to 1, 0 times pi, cosine of 0 is 1. N is equal to 2, 2 minus 1. Cosine of pi is what? Minus 1. So we're getting better, but not quite. We need cosine of 0, or we need to get 0 for the second term. So cosine of what gives 0? Cosine of pi over 2. So whenever n is equal to 2, we need to get pi over 2 here. So 2 minus 1 is 1. You get pi. So let's just divide this by 2. So n minus 1 times pi divided by 2. Okay, so n is equal to 1. You get 0 on the inside. That's cosine of 0 is 1. N is equal to 2. You get cosine of pi over 2. That's 0. Good. N is equal to 3. You get 3 minus 1 is 2 times pi over 2. You get cosine of pi. It's negative 1. There you go. That is your answer.